All right, today we're talking about factoring quadratic equations. All right, so we have two forms of quadratic equation: y equals ax squared, y equals a times x minus m times x minus n. Which one is the factored form?
First one.
First one, the left one?
Second one.
No. Which one is it, Sergio?
Second one.
The second one. Okay. This is our factored form. So we're going to try to get to here. All right, we're going to start with equations like this one, and we're going to try to end up with equations like that one. Okay? So we're going to start here and end there. That's our goal. Start with equations of this form, end with equations of that form. All right? Now, before we get going on factoring, we need to first know what are factors. Okay? If I talk about this number 6, what are the factors of 6?
3.
Greg, what'd you say?
3.
2 and 3, right? Okay, so 2 and 3 is a factor, right? Right, 1? Okay, so 2 and 3 is one factor. What's another factor?
1 and 6.
1 and 6. What's another factor? That's it?
No.
What about negative 2
No. No.
and negative 3?
No.
Yes.
Negative 6.
Nope. Negative 1, negative 6. Those are the factors, right?
Yeah.
Okay. So what are factors? Well, the factors of x are the numbers we multiply together to get x. Right? So the factors of x are the numbers we multiply together to get x. Does that make sense? You guys done that before, factors?
Yeah.
Marcel, you got a question?
No.
Okay, pay attention up here, please. Okay. Now, we've factored numbers like this before. Have you ever factored numbers like this?
Yeah.
No? Okay. What are the factors of 32? 1 and 32, right? What else? What'd you say, Sergio? 16 and 2, good. What else?
8 and 4.
8 and 4, nice. Okay, now what are the factors of x squared?
X.
X and
X.
x. So if I put an x right here and an x right there, won't those be the factors of 32x squared?
Yeah.
Yeah. So 2x and 16x. Won't those be the factors of 32x squared?
Yep.
Yeah. 4x and 8x. Yeah? Are those factors of 32x squared?
Yes.
Are those all of them?
No.
No, we have some of the negatives, don't we?
About 25 and 64.
Okay. We're only worried about whole number factors. Okay, so good question. 0.5 and 64 are a factor, but we're only worried about whole number factors for this. Okay, I should have been more clear earlier. Sorry about that. So, negative 1x and negative 32x, those are also factors of 32x squared. So, these are the positive factors. These are the negative factors. Right? Now, some of you might be thinking, I was waiting for Michael to ask this, what about 2x squared and 16? Is that also factors of 32x? Yeah. But we're not going to worry about these ones because when we factor our quadratic equations, we want an x in each parenthesis. Okay? So we're not going to worry about the 2x squared one and the 16. We're not going to worry about those ones. We're only going to worry about the factors where each one has an x. All right? Are there any questions about how we get the factors? Okay.
What is that?
The Valentine's, the singing grand.
What happens
What?
when they come in here?
I don't know. They come in here, then they get to be on YouTube, I guess. All right. So we know how to factor numbers. We know how to factor number with a variable. All right. But how do we factor this? What do we need to find?
Factors.
What two things do I multiply together to get something like this? We learned it yesterday. It's kind of like bicycle. Binomial, right? So to factor ax squared plus bx plus c, we need to find two binomials. Oops, it's not binomials. It's not biology class.
That would be binomial.
We need to find two binomials such that
Such
x plus m times x plus n equals ax squared plus bx plus c. Right? That's what we need to find. If we're going to factor, we need to find two binomials such that x plus m times x plus n equals ax squared plus bx plus c. Yes, Jared? Okay. Now, you're probably wondering, where does the B, where does the C come from? Is anybody wondering that?
No.
No, you're not?
No.
It surprises me.
Are you gonna tell us anyway?
I'm going to. Okay. Guys, yesterday we foiled this, right? If I were to take this and foil it, we do firsts, right? We do x squared. We do outers. We do inners. And we do last, right? Foil.
They do it back. Oh.
Okay. So the process we're learning today is going backwards. It's taking our foiled answer and unfoiling it, right? So if I look up here, what's in the same spot as the C?
The NM.
The NM. NM is C, right? So when we're finding our binomials, C is really going to be m times n. That's where our factors come in. Okay, that's why we're worried about these factoring ideas. Because what we're going to do to figure out our binomials is we're going to start with this C term. We're going to find the factors of C, and we're going to see which ones add up to what? You know? We're going to see which ones add up to B. Okay? Because if we look, our B term is really those two added together, isn't it? Right? This is our B term. And that's where the factoring gets tough. Okay? It's easy to find the things that multiply together to get our C. It's hard to find the things that multiply to C and then add to B. Okay? So, why is this important? Do we know? There's two forms, right? Will we always get quadratic equations like this?
No.
No. Will we always get them like this?
No.
No. So one reason why it's important is to know
Christian, I can't see.
how the forms, guys, relate to one another. Okay? So know how the forms relate to one another. One, pay attention, please. So it's important because we know how the forms relate to one another. Secondly, why is this form so handy? Why is this form so handy? Well, both I use plug into a calculator.
Oh.
What does this one tell me? What are the m and the n's? What are they, Lynn? X-intercepts. So if I can take something like this and rewrite it like this, then we can find our x-intercepts. Okay? Without using a calculator, without solving really, right? We can just find our x-intercepts. So why is this important? One is to know how the forms relate. Two is to be able, or to find our, oh, they're not ours, they're the parabola's x-intercepts. To find the x-intercepts for a parabola. Okay. So we need to know to find the x-intercepts for a parabola. Now this is not the only way to find the x-intercepts. We can also use the quadratic equation, which we'll study next week. All right, but this is how we can find it without using the quadratic equation. We can solve. We can factor one. Juan, go sit behind Travis, please. All right. Any questions about what I have on the board right there? Okay. In my next 11 minutes, we're going to factor one. Okay, this probably won't take the whole 11 minutes. All right, but try to keep up. Okay, so We're going to factor x squared plus 5x plus 6. Is this in factored or expanded form, Michael?
Factored. Expanded.
Expanded. Good. We're going to try to rewrite it in the factored form. Okay? So the first thing we need to do are steps. Okay? First thing we need to do is we need to find the factors of the ax squared term and the c term. Now, if I think of ax squared and c, well, where did I get ax squared and c from?
Factored one.
Nope. The expanded form, right? So we need to find the factors of the ax squared and c term. So find the factors of the ax squared and c terms. Gentlemen, Juan, you moved back there so you weren't talking anymore. So okay. All right. So in this equation, what's my x squared term? X squared. Right? What's my c term? 6. So we need to find the factors of x squared and 6. Now when I'm doing this on my paper, I like to make 3 columns. Okay? One is for my ax squared term. One is for my c term. What do you think the third one's for? Bx. Okay? The third one's for my bx term. Okay? So, let's find the factors. What are the factors of x squared? X and x, right? Any other ones?
Yeah.
Okay, I told you we're not gonna worry about the x squared ones, right, Chance? So x squared and 1, yes, that is a factor, but we're not gonna worry about those because we want an x in each of our parentheses. Good. Negative x is also an option. Okay?
I told you.
Because x times x is x squared, right, Sasha? Okay, so we're just finding the factors of x squared. Right? Now, factors of 6. 2 and 3, what else?
1 and 6.
So you got 1 and 6.
-2,
Negative 2, negative 3.
-1, -6.
Okay. So those are the things we multiply together to get 6.
Yes.
Right? So step 1's out of the way. Alright, step 1's out of the way.
What's 5?
What?
What's 5x?
We'll get to the 5 in a second. Okay. Step 2. We need to find the combination of the factors of ax squared and c that multiply and add to bx. This is the b, now 6. Okay. Now what's our bx up here? 5. The bx is a 5x. So I know that step sounds like a long and complicated step. You see multiply and add, right? It's not as difficult as you think. Okay? It's not as difficult as you think. Because when we foiled, right, we multiply the x term times the non-x terms, right? So what we're going to do is we're going to find what combination of x factors multiplied by factors of 6 that add to 5x. So what I mean by that is we're going to do x times 1 plus x times 6. Okay? What's x times 1?
1x.
1x. What's x times 6?
6x.
6x. What do those add to?
7x squared.
No, just 7x, Michael. And x squared, we need to multiply to get x squared. Okay. So just 7x. Is 7x the same as 5?
No.
The next one works.
Is 7x the same as 5? No. So does this combination work? No. Okay. So now, since this combination doesn't work, x and 1 and 6, we'll try 2 and 3.
Oh, I get it.
So x times 2, x times 3. What's x times 2? 2x. What's x times 3? 3x. 2x plus 3x, does that equal 5x? Yeah. So we found our combination that equals 5x. Okay, we found our combination that equals 5x. Okay. Now the last one for all you basketball players is the sickest crossover you'll ever see. Yes. You'll see. What? If we had to, we could use the negatives, but we don't have to because we found our answer. Okay? There is another combination that'll work with both negative x's and both -2 and 3, but we don't need it. We want to find the simplest one without the negatives. Okay? So that sick crossover I was telling you about. Number 3. Okay? Third step. Write 2 sets of parentheses. Can't spell parentheses, so I'm just going to write it. So write 2 sets of parentheses.
Yeah, I can't.
Yes, I just drew parentheses. Now we're going to drop down the x factors. Drop down the x factors. You'll see. We're getting there. See, dropping down the x's, just set it up. So we drop down the x's. So x and x. That's where the crossover comes in, Travis. And cross over the c factors. So, which one's up here are my c factors? 2 and 3. Now, if I'm going to do this x times that 2, does that have to be the same parenthesis or a different one?
Different.
Different. So this 2 goes there. There's the crossover for you, Travis. Okay. And this 3 goes where? To that one. And guess what we've done? We crossed them over and we factored. Okay. So we took an expanded form and rewrote it in factored form. Okay. Now this is so useful because now I've found my m is -3 and my n is -2. So that means this parabola, which is the same as this parabola, crosses the x-axis at -3 and -2. Yes, Craig. In this one, it does not matter if you cross them over because these x terms are the same. Okay, these x terms are identical. Later on, when we have a number in front of the x, like a 2 or a 5, then we got to make sure that this one goes in the opposite parenthesis as the correct one. So if I had like 2 here and 3 there, then I had to make sure that the 2's were in opposite ones. Okay, and that'll make more sense later on. All right, any other questions?
No.
No,
Okay.
Okay, bye.